Hello everyone, welcome to yet another video of measurement and instrumentation. In today's video, we will be discussing about Schering Bridge. In previous class, we have discussed about Maxwell's bridge. So, Schering Bridge, Maxwell's bridge are a type of AC bridges used for measurement of unknown impedances and its parameters. So, Schering Bridge is useful for measuring insulating properties, which is of phase angle nearly 90 degrees. The Schering Bridge is used for measurement of unknown capacitance of a capacitor, or it can be used for finding dissipation factors and insulation properties, capacitor bushings, insulating oil and other insulating materials. So the Schering Bridge is used for measurement of capacitance of these values. It is one of the most commonly used AC bridge. The Schering Bridge works on the principle of balancing the load on its arm. Let us discuss about the construction of the Schering Bridge. The capacitor C1 is connected. The capacitor Cx is connected to one of the arm along with a resistance connected in series which is Rx, and this Cx value is the capacitance whose value is unknown. A series resistance Rx representing the loss of capacitors unknown resistance Cx is connected. A standard resistance and standard capacitance C1 and R1 is connected. The C1 is assumed to be free from loss. A non-inductive resistance R2 is connected at one arm, and a variable capacitor C3 is connected to the another arm. And a non-inductive resistance R1 is connected in parallel with a variable capacitor C1. So this is the construction of the Schering Bridge. The parallelly connected Cx and Rx is variable, whereas the rest of the arms are standard. When the bridge is in balance condition, zero current passes through the detector, which shows the potential across the detector is zero. So at balance condition, Z1 by Z2 is equal to Z2 by Z4, or I can say Z1 Z4 is equal to Z2 Z3. So by substituting the impedance of each arms, the unknown resistance value and unknown capacitance value can be found. So the unknown capacitance Cx is given by C2R4 by R3. So from this equation, it is found that the unknown capacitance is free from frequency. Also, the unknown resistance value can be found, which is Rx is equal to R2 C1 by C2. The dissipation factor can be obtained with the help of phasor diagram. The dissipation factor determines the rate of loss of energy that occurs because of the oscillations of the electrical mechanical instruments. So this can be easily found by using the phasor diagram. The advantages of Schering Bridge is that the balance equations are free from frequency. So from the balance condition and from the output equation, it is found that the Schering Bridge is unaffected from frequency. So the balance condition can be easily achieved irrespective of the changes in frequency. And the arrangement of the bridge is less costly as compared to other bridges because the capacitors are cost less compared to the inductance. So with this, we come to the end of this video. We have seen about Schering Bridge, which is used for measuring capacitance and insulating properties, and we have seen about the construction of the Schering Bridge, and we have discussed about the derivation part, which includes the measurement of unknown resistance and unknown capacitance value, and finally we have seen about the measurement of dissipation factor and the advantages. So the formula for finding the dissipation factor is d1 is equal to omega c3r4. So with the help of this equation we can calculate the value of the dissipation factor, which is given by tan sigma, which is nothing but d1, or we can say it as tan sigma is equal to omega c1 r1. So I hope this video is very useful to you. In the next video I'll meet you with yet another bridges. Thank you.